All right, before I show you, this will be 5-3. I'm going to do it in two parts. Part one, I'm going to do a reminder. We may not have gotten to this. Reminder kind of how to get more than one solution for a trig function. So here's the sine graph. And the sine graph, like the cosine graph, the tangent, all the trig functions, they go forever. They're infinite. And a lot of times, this will help us with the solving, which I'm going to explain this first, and then we'll do the part two. When is sine a half? Okay, so if we don't have a calculator, we could go, well, sine of 30 is a half. I can see that right there in that triangle. But if you ask your calculator, hey, arc sine of a half, your calculator will give you your first answer, 30 degrees. Well, the calculator's done. He goes, I got 1. There's an infinite number, and the calculator goes 1. Your calculator gives you the closest one to 0. So here's 0. Your calculator gave you that one. So you can see how close I am to 0. I'm going to go, here, I got 1. Okay, but I can clearly see, if I draw a line through a half here, the sine graph crosses a half, just in what I'm showing you here 6 times. So it crosses an infinite number of times. Okay, so how do you get the other answers? Well, if we remember our system, sine is positive 1 and 2. Since we're looking for when sine's positive half, the two answers that we're looking for are in the first and second quadrant. That's the only time sine's positive, 1 and 2. So remember our reference angle. We have to go 30 degrees in quadrant 2, which is equivalent to 150. So our second solution is 150. So we give the answers in degrees. If they say 0 to 360, you might notice that notation, just saying, hey, from 0 to 360. But if they say from 0 to 2 pi, it's the same question. You just have to give it to in radians. So 30 is pi over 6, and 5 pi over 6. So we were starting to do that right before we left. Those are our two solutions, all right? Now, what you just found were these first two solutions. Because the period of sine is 2 pi, you will have those two solutions from there. So your calculator will give you the closest one to 0. You use your brains, your quadrant system to find the second answer. All right, now we got the first two answers. What we did get to, which I kind of assigned some of these last week without showing you, so I'm kind of showing you it right now. Theta is any angle. Okay, so theta could be any angle. In other words, we're not restricting us from 0 to 360. We want all the answers. I'm like, well, there's an infinite number. How do I list them all? So we have a technique and a notation that we do to list it. So typically you'll see a bracket, and you might see that says, that's just saying my answer is in terms of theta, and a colon in math means such that, just as the word such that. So hey, theta such that, and then you're listing the answers. If you didn't write that, it's just part of the notation. You're not writing the wrong answer. All right. Now theta, we know is 30, and we know theta is 150. That's just those first two. I wrote them this way for a reason. How do I write the other answers? Well, since, if you remember from the last year, the period of sine normal is 2 pi, which means its answers repeat every 2 pi. So if we were to rotate around this, 30 and 150, but if I were to rotate around, I would hit those answers again. As I spin around, I'm keep hitting those answers. So they're 3 full circles, 360. That's why its period is 360. We will find the answers repeated. So if you look right here, these next two, if I were to add 360 to these, just the 360, you're now listing these two. So that's 30 plus 360, that's 390. So you're listing that one. 150, that's that one. Well, then what about the next two? Well, I got to add another 360. So what we do, instead of just writing one of them, we put n, and what we're saying is we're going to add 360 a number of times. Okay? Now we got to say what n is. N can't be a fraction because we have to add a full 360. So it's got to be a whole number, integer. Now if I said n was a whole number, then you're only going to list all the answers going in the positive direction. But if I went back 360, then I get those. So technically you could write plus or minus here, and then that will take care of it. So if we just write plus, we have to somehow at the end say n. Now I'm going to write it bigger so you guys can see it. That is saying n is that's a Greek letter epsilon. N is an element of z. The letter z stands for integers. So n is an integer. If you don't like the notations, you can just say n is an integer, okay? If you do not write that, you're technically incorrect. I would disagree with you. So, because you can't say, hey, 360n, and I'm not going to tell you what n is. So don't be lazy. Either write n ez or n as an integer. Pick one, whatever makes sense to you. All right? And that's how you list all the answers. Now, sine and cosine are very similar because their periods are 360. So I wrote sine here. I meant to do cosine. Well, I was going to do sine. I'm sorry. I did mean sine, because that way you don't have to change the graph right now. Cosine would be very similar. It'd be plus 360n and so forth. Now, if I was doing radians, I'll do the next one in radians. Okay, so you can see what that looks like. All right, what is sine root 2 over 2? Well, if you remember, sine of 45 is 1 over root 2, which cleans up to be root 2 over 2. But you notice how it's negative. So the two answers are down here. Now, your calculator will say negative 45. Well, that's down here. Another name for negative 45 is 315. So you can use either one, but it does. If you say them both, you're being redundant. They're the same answer. And then we know the other one's down here because remember, sine is positive 1 and 2, so it's negative 3 and 4. So I have to be in 3 and 4. So if I go 45 down here, that's 225. So my two solutions are 225 and 315. Now, why did I pick 315 over negative 45? The direction said give me an answer between 0 and 360. If I said pick a number between 1 and 10, you wouldn't say negative 2. You're not very good at this game, right? So 0 to 360 means give me an answer in 0 and 360. I know your calculator said negative 45 because your calculator is giving you the fastest answer it can. But I want the answers over here. So if we look at where that is, I want these two answers. And your calculator goes, got one. We're like, well, thanks for helping, but that's not the one I wanted. So I probably made this a little bit too low. It's a little bit higher than that. But we want the two answers here, which are 225 and 315. So in radians, that's 5 pi over 4 and 7 pi over 4. If they ask you that, you just convert them. So what if we had to give every single answer? Well, theta, you could just list the two answers. Let's go ahead and do radians this time. Okay, you could do it degrees or radians. If they give the problem in radians, you do it in radians. And if they give it to you in degrees, do it in degrees. And what is 360 in radians is 2 pi. So it's 2 pi n instead of 360n. It's the same thing, it's just using that notation. And again, I need to tell somebody that n is an integer. I gotta make a comment on that. So that's how you list all the answers. You just find the first two that we did before we left, and then next to them you just put plus 360n, and that's how we give an infinite. Now I notice in Alex they don't use n. They were using k. So this would be 360k, k, or k is an integer. Okay? So you can use any letter you want to as long as you just tell them what it is. So you say, hey, k is an integer. All right? So I only did sine because I had the graph, but if I did cosine, I would do it the same way. Tangent the same way. Tangent's got a couple special properties. So let's say we're looking for tangent of negative root 3. So tangent of negative root 3. All right, tangent of 60 is root 3. Tangent of 60 is root 3 over 1. Now your calculator will give you, it won't say 60, it'll say negative 60 because you have the negative angle. But what your calculator is doing, tangent's positive in these two, and it's negative in these two. Since we're typing a negative, if you type in the negative, your calculator will go down here 60. A little trick sometimes is I type in without the negative sign, it will always give me the reference angle in quadrant 1. So I always get the reference angle right away. It's a little shortcut, all right? Or use my triangles. So, whoops, wrong way. But I want you to notice, see how that's it looks like a straight line? It is. It's actually 180 degrees. Tangents answers, because they're positive in the opposite corners and negative in the opposite corners, their answers are actually 180 apart from each other, which is kind of cool. So I'll show you a little shortcut in a minute. So when's tangent negative root 3? Well, we know tangent of 60, but we're looking for negative. So 60 down here and 60 down here, or up here. So this would be 300 and 120. All right. So 120 and 300 because, again, I have to answer between 0 and 360. I know my calculator said negative 60. That's not a wrong answer, it's just not what I'm asking for. Give me 0 to 360. All right, if I did that in radians, that's 2 pi over 3 and 5 pi over 3. All right, doesn't matter, you know, but that's what the radian value is. All right, and just so you know, when we get to calculus, we do everything in radians, so we just get used to it. This is the year you learn to convert, so don't dodge it completely, but you can get by with most of it being degrees. All right, so how do we give all the answers? Again, just like with sine and cosine, I can list each one. I'll go ahead and do degrees. And I could do the 360n, where n's an integer. But what I could have done that was really special, because this doesn't say give me 0 to 360, I could just do anything. I can do what my calculator said, negative 60, and then just say plus 180n. You're like, I've been closing these off, but you get the idea. I'm like, why can I write it so short? Well, if we look back at our picture that I erased, those are 180 apart. So your calculator gives you the first answer. If you add 180, you get this one, add 180, you just keep getting the next guy. If you add 360 each one, you're just skipping every other guy. And so each one's doing every other guy. And then it's a little shortcut. You can't do that with sine and cosine because they don't repeat like that. Only tangents, the two answers you get are always 180 apart. Always. So that's a nice little thing about tangent. And that's, remember, the period of tangent is pi, not 2 pi. Because the period of tangent is pi because it repeats every pi its answers. Okay? So tangent, cotangent have this property. They're the only two guys that are special for that reason. All right? So that's part 1, and then I'm going to show you some solving.